Hi guys, welcome to this set of videos. What we're going to do here is we're going to start a section of videos that is all going to deal with Chapter 6, Section 1. Now what we're going to be doing here in Chapter 6 is really our theme is going to be dealing with radicals. All right? These are going to be expressions that have a radical symbol in them, whether it be a square root, a third root, a fourth root. But before we get to those kinds of expressions, the first thing we want to do is take a little bit closer look at operations that we can perform on functions. Now, while I'm calling it a different name here in Chapter 6, Section 1, we're going to call it operations on functions. You're going to recognize this. You're actually going to recognize it from the previous chapter where we did something called operations on polynomials. It's actually the exact same thing. We're going to be adding, subtracting, multiplying, and dividing polynomials, but instead of calling them polynomials, we're just going to call them functions instead. So please do not get confused. Remember, a polynomial is just a function with many terms. In fact, in the last chapter, we looked at calling a polynomial a function, and then we looked at graphing it, performing operations on it, right? Same idea here, except now, instead of calling it a polynomial, we're just going to call it a function. But we're going to do all the same stuff. You'll recognize the process, right? Combining like terms. If there's a minus sign, don't forget to distribute. When multiplying, we'll have to use the distributive property to multiply all the terms together. And yes, when it comes to division, you'll have to do either the algebraic long division, or if it's one of the cases where it works, synthetic division to divide these functions. So it's just like what we did in the previous chapter with polynomials. One other quick thing to mention here is your objectives or learning targets before we jump into it. The things you'll need to be able to do is you'll need to be able to find the sum, the difference, the product, and the quotient of functions. Like I said, we'll be adding, subtracting, multiplying, and dividing functions. Just like we did for polynomials, it's going to look exactly the same. And then the last one here is going to be find the composition of functions. These are going to be composite functions, and we'll talk more about those when we get to them in the second half of this set of notes. Now, a real quick note here about this stuff. We're going to choose functions. We're going to let f of x and g of x be any two functions. And this is the quick note I want to make before we jump into it. Please recall that f of x and g of x are just names. Remember, I told the story, the Dr. Seuss story about the lady who had a lot of children and she named all of her children Dave. Because she named them all Dave, she couldn't tell them apart. Same thing here. Since we're going to be performing operations with functions, I can't name all my functions f of x, or I can't name all of my functions y, because then you won't be able to tell them apart. So please remember that these are just different names. I'm calling one function the function f. I'm calling another function the function g, right? You could use many different things. You could use t of x. We could do s of x. We could do w of x, right? You can name the function anything. You can name it after yourself if you want to, right? It's just a name to distinguish the function from other functions. So when I ask you to do f of x minus g of x, you'll know which function goes first, which function goes second. And keep in mind, subtraction is not commutative, which means f of x minus g of x is not the same as g of x minus f of x, right? So that's why I have to name them differently so that you know which one goes where, right? So it's just naming. That's all we're doing, just naming the functions differently so we can tell them apart. Now, the operations that we're going to have you do, I've got listed for you right here. You'll be adding functions, we call it a sum, subtracting functions, we call it a difference, multiplying, we call it the product, and division, which of course we call the quotient. These are just different ways of writing it. I'll go over that more as we do some example problems, but most of the time you're going to see the sum of functions written this way, which looks a little bit confusing. You want me to add f and g? No, remember it's function notation. So another way we might write it that'll make a little bit more sense, right? This f plus g of x, f plus g of x means f of x plus g of x. Add the function f of x to the function g of x, right? Down here, we have f minus g of x, f minus g of x, which is just simply f of x minus g of x, right? Means the exact same thing. F times g of x, same thing would be f of x times g of x. So just asking you to multiply the functions together. So be okay with seeing it written in either of those forms, and we'll get practice with that as we do some example problems. So let's jump right into some of these example problems on the next page. All right, here's what we've got. I've given you two functions, f of x and g of x, and in the first one, I asked you to add these two functions. All right, now it's written in kind of that weird form. You look at it and you're like, you want me to do f plus g? No, remember this is function notation. What they're actually asking you to do is they're asking you to do f of x, the function f of x, right there, plus the function g of x, which they've given you right here. So that's just simply going to be f of x, which is x squared minus 4, plus g of x, 2x plus 1. Combine like terms if you have any. X squared doesn't have any like terms. 2x doesn't have any like terms. But I can combine the negative 4 and the 1 to get a minus 3. And this is the function, my new function, it's my sum function, right? The sum of f of x and g of x. This is what you get when you put them together. Now, just like with polynomials, when it comes to subtracting functions, sorry, I need to be able to see my function still. When it comes to subtracting functions, don't forget parentheses, because you're going to need to distribute that minus sign. Let me show you the way that you could rewrite this if you wanted to. If you didn't like the way that was written, you could do f of x minus g of x. But since you're subtracting the function g of x, you'll need parentheses so you remember to distribute the minus sign, just like we did with polynomials. The exact same thing happens here. So I'm going to have an x squared minus 4, because that's my f of x, right? But then I'm going to subtract, make sure you use parentheses, I'm subtracting 2x plus 1. And the reason I need the parentheses is so that I don't forget to distribute that minus sign. So let's go ahead and do that just like we did for polynomials. Distribute that minus sign. X squared minus 4 minus 2x minus 1. Combine like terms if you have any. X squared minus 2x minus 5. And just like with polynomials, we'll write our functions in descending order of power, making sure we combine like terms. Let's try a couple more. On this next page, f of x and g of x, right? Just two different names for the functions. This is function f, this is function g. The x just simply means that my variable is x, right? Please notice that x squared plus 5x minus 2, right? The variable is x, so this is the function f in terms of x. This is the function g in terms of x, right? My variable is x. So once again, if you don't like that, the quantity f plus g of x, you could just simply rewrite it as f of x plus g of x, right? And again, what that means is I'm taking f of x, which is x squared plus 5x minus 2, right? That's my f of x. I'm going to add to it my g of x, so plus 3x minus 2. Combine like terms if you have any. 5x plus 3x is going to be 8x. And a negative 2 and a negative 2 would be a minus 4. And so this is my new my new sum function by adding f of x and g of x. Same thing down here. Again, if you don't like that notation, that's fine. Go ahead and rewrite it. F of x minus g of x. You just got to be really careful here that you remember to put g of x in parentheses so that you distribute that minus sign. So I'll have x squared plus 5x minus 2 minus, don't forget to put it in parentheses, 3x minus 2. So I go ahead and distribute that minus sign through the parentheses. and combine like terms if I have any. X squared, 5x minus 3x is going to be plus 2x, and a negative 2 plus 2 is 0. So those cancel each other out, and this is my difference function, what I get by doing f of x minus g of x. All right, I've got a couple more example problems on the next few pages. If you feel comfortable with this, go ahead, work on ahead of me, and then come on back, check your answers with what I get just to make sure that you're doing it correctly. But here we go. If you're coming back to check on how you did, we got a couple more for you here. And now that we've had some practice with rewriting those if you don't like them, I'm going to skip that part and just go straight into solving these guys. So here we go. I've got x squared, because I'm going to do f of x plus g of x. So x squared minus 3x plus 1 plus 4x plus 5, which means I get x squared, negative 3x, positive 4x is going to give me a plus x, and 5 plus 1 is going to be a plus 6. So there we go, my sum function. This one down here, subtracting, don't forget to put it in parentheses, x squared minus 3x plus 1 minus, put g of x in parentheses, 4x plus 5, distribute that minus sign. And let me slide up so you can see it. There we go. Combine like terms. Going to be x squared, negative 3x minus 4x minus 7x. Let's see. And then a positive 1 and a minus 5 is going to be a minus 4. There's my difference function. Okay, let's go ahead and do another one. Let's see what we get. Got another one for you here. We're going to have x squared. Adding and subtracting, so we'll just do it the exact same way here. I'm going to wind up with x squared minus 5x minus 2 plus 3x minus 2. Combine like terms. Negative 5x plus 3x is going to be a minus 2x. Negative 2 and a negative 2 is going to be a minus 4. Same thing down here, just don't forget to distribute the minus sign. In fact, I'm just going to write it by distributing the minus sign. I know that this will now become negative, this will now become positive, so I'm going to have x squared minus 5x minus 2 minus 3x, right? Because when I distribute that minus sign, that'll become a negative 3x. Distribute that minus sign, that'll become a positive 2, so minus 3x plus 2. Combine like terms, x squared, that's going to give me negative 8x. And the 2's cancel each other out. So that's it. That's my difference function. Let's go ahead and do another one. I think I got 2 more problems for you here. Actually, I don't. That was it. Those were my last 2. So hopefully adding and subtracting functions makes sense. Again, just don't forget to distribute the minus sign if you're subtracting functions. And again, it's just like what we did with adding and subtracting polynomials. So head on over to the next page of the notes. We'll look at multiplying and dividing functions, which was just like multiplying and dividing polynomials. So I'll meet you guys on the next page.